Welcome to section 1.6, the last section of this chapter. So I'm just going to jump right into it and say that in example 1, we've got to solve the inequality. Here's an inequality. 3x minus 5 should be less than 6 minus 2x. There's a lot of values of x that are going to solve this, that are going to be solutions to this inequality. So let's find them all. You do the same, basically very similar to the way that you solved equations. So if there were an equal sign here, you could just add 5 to both sides and get 6 plus 5 is 11. Adding 2x to both sides, you get 5x is less than 11. Dividing by 5, you get 11 fifths, or what I think it's a lot easier to graph decimals always. So anytime you've got a number line or a xy plane and you got to graph something, change it to decimal if you can. Just your life will be a lot easier when it comes to graphing. Because you can see very easily that 2.2 comes kind of right here in between 2 and 3. Now, we can see there's this less than symbol right here. If you forget which way to shade, you just notice that this symbol agrees with this arrow that you should shade in. So it's pointing this way, you can shade. X is less than 2.2 for all of these values, not including 2.2, but everything below it. So 0, 1, 2, 2.1, 2.19999, all those values will be values that you can put into the original inequality and get a true statement. So that's what it looks like. Notice the parentheses right here, because we don't want to include 2.2. Next example. Yikes, where am I going? Example B. Notice very similar, except we've got a greater than or equal to symbol. So when we add 7x to both sides, we get 17x. When we add 4 to both sides, we get 17 equals 17 is greater than or equal to 17x. And then what I'm going to do right here is I'm going to flip it around. I'm going to change it so that it's just a lot easier to graph things when the x variable is over here. So you can finish this out and just know that when you graph it, it looks like this. You can see the bracket and then go like this. This trick that I talked about before, where you can line up the arrow, the arrow and the symbol here and the arrow on the number line here. That only works when the variable is on the left-hand side, which it is right here. If the x were over here, you wouldn't be able to use that trick, but because the x over is here, you can use the little trick. The symbol and the arrow here shading are pointing in the same direction. All right, next. Example 2, find the domain of the function. Domain of the function. So this is, students get really tripped up on finding the domain. It's kind of a tricky question to ask because what you have to do is figure out all the values that will produce an output, all the input values that also have corresponding outputs. And some of them don't. Here are the three kind of areas where you have to restrict the domain. The first one comes from square roots. If we are talking about real numbers, I mean not imaginary numbers like I, if we're talking about just real numbers, then we have to make sure that what's inside of the square root is either 0 or positive. It can't be negative. So when it says find the domain, first category for finding domains would be square roots. You look within the function and you try and figure out when is what's inside of the square root going to be greater than or equal to 0, as I've written here. So when is x minus 6 greater than or equal to 0? When is it going to be 0 or a positive number? Well, you add 6 to both sides. X can be greater than or equal to 6. That means x can be equal to 6, it can be equal to 7, 8, 9, 10. That's fine. Any of those numbers, and you'll get, you don't have to worry about getting a negative in the square root. So all of these numbers here are in the domain. The domain of the function is x is greater than or equal to 6. And you can graph it like this. For all of these values, you'll get an output of f. The second time, you kind of have to worry about an input not producing an output whenever you have a fraction. We already know that if you had a square root, you have to make sure that what's inside the square root is 0 or positive. If we're talking about real numbers, then you have to make sure that this is true. You also have to make sure that you don't get zeros in the denominators. That's we've defined division in such a way so that we shouldn't even ask the question, what is 3 divided by 0? What is 10 divided by 0? What's anything divided by 0? Because we don't have an answer for that. It's undefined. You can't answer that question. So in order to make sure that we have values that produce outputs over here, we have to choose x values so that what's in the fraction does not produce a 0, or what's inside the square root does not produce a negative number. So anyway, what I'm trying to say is that this 3 minus x right here has got to be greater than 0 only. Over here it was greater than or equal to. Over here it's greater than. It's greater than because we need it to be either 0 or positive, but actually we can't let it even be 0 because it's both in a square root and it's in the denominator of a fraction. So really 3 minus x has got to be a positive number. It's got to be greater than 0. Can't be equal to 0. Subtracting 3 from both sides, you get this, and then when you divide both sides by a negative number, you have to flip the sign. So you get x is less than 3. For any value when x is less than 3, then you'll get an output here in h. So for example, 0, 1, or 2. You put 0, 1, or 2 in here, and you'll get positive numbers, not 0 numbers, not negative numbers in this denominator, and then everything will be just fine. The way you graph it is it looks like this. 3 parentheses less than. Notice, since the variable is on the left-hand side over here, then you can see that you can use this trick. The arrow and the symbol are pointing in the same direction. Next, example 3, solve and graph. Here we've got 2 symbols over here. What you've got to be able to do is you've got to be able to solve for x. Your goal is to put x all by itself right here and just get numbers on the outside. The way you do that is you undo the addition, you undo the multiplication, and you get negative 4 is less than x is less than or equal to 1. So the way you graph it would look like this. Notice you would need parentheses over here, and you would need a bracket over here. But x is allowed to be any of these values in between, and even including 1. X is allowed to be 1. If x is any of those values in this original inequality, then it'll be true. That the left-hand side in the middle would be less than, the middle would be less than or equal to the right-hand side. Next, we've got an or statement going on over here. So what values of x will make this true or will make this true? If either one of those are true, then the overall statement is true. Again, add 5 to both of these sides and divide by 2. And add 5 and divide by 2, and you get x is less than or equal to 1, or it could also be x is greater than or equal to 3. And it looks like this. Each of these two halves get graphed like this. X is less than or equal to negative 1, bam. Notice the bracket, meaning that you could equal negative 1. And then x is greater than 3, so here, we're not including 3, we're including everything above 3. Example number 5. Income plans. For a house painting job, Erica can be paid in one of 2 ways. She's got plan A of $250, just a flat fee of $250 plus $10 for every hour. Sometimes people use this as like charging for paint supplies. Like, these are all the supplies that I have to buy for you, and then parts and labor, the $10 in labor. $20, or she could just charge people $20 an hour. And the real question is, when is plan B better for Erica? Well, the things we know are A is $250 and $10 an hour. Plan B is just $20 an hour. The unknown is the amount of time, and we'll leave that in hours. So really, when is plan B better for Erica? When is the value of B going to be greater than the value of A? Well, B is $20 an hour times the amount of time. That's how much money she's going to get for plan B. And then when is that greater than A, 250 plus 10t? You subtract 10t from both sides, you get 10t is greater than 250, and then t is greater than 25 hours. So if it's going to be a long enough job, if it's going to take more than 25 hours, then she should go with plan B. Just wanted to put it out there that I had a lot of fun playing some musical instruments in high school and college. I played the violin, the trombone, the drums, and I even sang vocals. So why don't you tell me what musical instruments you play, if any, or even what music you like when you see me in class, and I will see you in class after you finish. Oh, make sure you, of course, you finish the assignment, the first problem on the assignment 1F. That's required when you come in, and I will see you in class.